Is the sound check done it? Yeah, perfect. Well, we live? Yeah, okay. Very good. Thanks everybody for joining us. My name is Shane Murphy from the technical and the sales department. I'm director responsible for both. I'm joined today by my colleague John Allen, standing to my right here, and my colleague Brian O'Mahony, who's our head technical guru. So he's here to make sure I don't make an ape of all of us. So the purpose of the webinar today is, whether you've bought solar from us in the past or whether you've bought it from somebody else, we don't mind. The purpose is, I suppose, to over time that we help raise the level of awareness within the industry and within, I suppose, the general public about, in this case, solar panels. You know, there's a lot of poor information out there. You know, we seem to think that most of the great decisions are made in the pub. And I've learned, we hear all the time, my friend told me this, and inevitably it was while they were having a pint, and his friend is the world's leading expert in battery technology and inverters and all of this stuff. And we're sick, apart from being sick of hearing it, we just want to make sure that over time, homeowners, as I say, whether they bought stuff from us or not, it doesn't matter, that we're, I suppose, helping people to make good decisions and improve over time. And today we're discussing solar. So what I would say is a few things you'll see here at the bottom of our presentation in a second. Johnny doesn't let me down. You have a Q&A button there. There would be a lot of questions on this seminar. There's quite a big number there. We're expecting a lot of questions about batteries and string inverters or hybrid. Should I charge my car by night or by day, or what electricity supplier should I use? We're expecting all of those things, okay? And so it's that type of talk. We're not going to be getting very technical, hopefully. Inevitably, maybe at 1 or 2 points, we'll have to go into watts and maybe kilowatts or something like that, but it won't be an overly tech. This is for the lay person and for the person who over time wants to improve their savings, and I suppose to make sure that they're doing the correct things. And if we walked into 10 different houses, there might be 10 different correct ways of operating, okay? So whilst it's a difficult presentation, by the way, to do, because we're trying to cover a lot of things in a short space of time without getting technical. So I would say put in your questions as soon as possible. If we have any professionals on the line who need CPD points for their continuous training, let us know in that and we'll get you back your certificates. A tiny bit about Ashgrove. Again, this is not a salesy talk, but just some of you will know us, some of you won't. We're in business since 2001. We're in renewable energy actually since 2001, since the start. We're a registered one-stop shop. That's not really so important, I suppose, for solar, but what it tells us is that, or what it tells you is that we're one of a smallish number of qualified people in the country to look after kind of home or whole house energy upgrades. And obviously there's grants going with all of that, etc. The community energy grant, despite the wonky name, it is mostly to do with, in our case, houses. You can do commercial properties through it as well, and you can do community projects like community centres or whatever it is. And again, those grants are all to do with SEAI. I'll skip that. We did just under, just over 17% of the projects in the country last year that were home energy upgrade related through the one-stop shop or through the community energy grants, if we exclude the approved housing bodies. Anyway, that's really not to boast, but to tell you, I suppose, we're doing a lot of them and we know the recipe. We do everything to do with home energy, insulation, ventilation, heat pumps, solar, or whatever else. And we do anything from small projects up to large projects. The large, in the case of a house, would be vacant and derelict grants, so total revamps. We have today, it's over 60 people in the office. A lot of them are there to do with grants and grant paperwork, but also, more importantly for you, a lot of them are there for advice, and they're obviously there for after sales support and so on as well. We do a lot of these webinars. That's part of our commitment, I suppose, as I said at the start, to improve the level of awareness. We can see over the last, like as we said there, we started in 2001. Over the years, obviously, the uptake in renewable energy has grown immeasurably, but part of that is mandated through building regulations and so on, but part of it is driven by government subsidies and grants. But along with it has not, the level of understanding probably hasn't grown with the level of uptake. So we would often regularly meet installers of heat pumps, maybe, for example, or whatever it is, who don't understand the difference between a kilowatt and a kilowatt hour. For us, that's a fireable offence on the spot, or a shootable offence maybe. And, you know, people who just kind of, they're doing it, but they don't understand it. They're not even interested in it. So we have a lot of geeks in the office here. So we, I suppose, within the four walls have the knowledge, and we're happy to share it and improve things over time so that homeowners, I presume most of the people who are on here are homeowners. The other maybe half will be architects, engineers, and so on. And either way, we just want to share knowledge and help. Obviously, we get business along the way. We know that. That's naive if we weren't going to say that. Grant.ie, that's an app we have for anybody facing into home upgrades as opposed to just solar. The various grants are explained in kind of short 5-minute videos. Skipping on. There's a professionals hotline for any professionals here. Are put directly onto a separate line within the building here, so that they're talking to maybe engineers more so than they'd be talking to advisors straight away, and all calls are answered. Anyway, CPD points we've mentioned. Okay, so what can you expect from today? So we'll, I suppose our aim here, and we were unsure of the way we would run through this, but I think we have decided to start with your consumption, and then how you would improve your consumption over time, right? So by refining, I suppose, your behaviors. Could you be using slightly different philosophies, charging your car or running your tumble dryer, or, you know, should I export my electricity, or should I try to consume it if I have a surplus? Energy monitoring, like these little energy monitoring devices. Now we have some of them there on the slide. You can get them wherever you want. They're no longer so expensive. You can get them for as little as €15, and they're quite, you know, simple little things. You know, if you're in a commercial building, you might want something a little bit more sophisticated. But again, it helps you over time to understand, okay, the kettle, for example, draws a lot of power, but it's only for a few minutes. And then it's so over the year, it amounts to quite little, whereas lights consume quite little, but over the year, they can amount to quite a lot, etc. So we talk about the electricity suppliers. It probably a lot hinges here because most people put in the solar and they think they're done, and they might be better off sometimes changing suppliers. Well, you should always threaten to leave your supplier at the very least, so that you get the best rates. But sometimes there's, depending on your lifestyle or on your system, or do I have a heat pump, do I have an electric car and I'm working from home, whatever it is, you know, all of those things dictate I should do this or I shouldn't do this or whatever it is. So we'll try to cover that and give you some, hopefully, some bit of a feel for it without getting too scientific. And so that's one of the big ones, the car charger. And then we will also give you an idea of expected generation. This is a big one. We'll say we would see a lot of houses putting in maybe a kind of a system around 6 kilowatts. So, you know, a lot of people don't know what a kilowatt is, but some people do. So they expect that if I have 6 kilowatts in 1 hour, that's 12 kilowatt hours in 2 hours. And I just multiply it by 8,760 hours in the year, and sure, jeepers, I'm going to be loaded, you know. But just because I'll have 6 kilowatt in 1 hour doesn't mean I'll have it in the next hour, and I certainly won't have it at night in winter. And so we give you rule of thumb. What would I expect from a panel? What would I expect from my system? Now, we'll have people in Donegal and we'll have people in Kerry where it's raining more than it is in Dublin. We'll have people from everywhere on the call. We'll give you a ballpark, and we're happy to answer your questions as we go. Or, by the way, there's somebody else outside the room here as well watching questions coming in, and we'll type answers if we won't get to answer them. We'll talk about batteries. This is the big one. Should I have a battery? Should I not have a battery? My friend down the pub said he had a battery. You're wasting your time if you don't get batteries. We hear it every day. And we'll talk about the pros and cons. And obviously there is no con other than the fact that you have to pay for it. And if I'm paying 2 or 3 or 1,000 or whatever it is for it, will I get my 2,000 or 3,000 back? And if I won't, I shouldn't have a battery. Some people, you know, get emotional about it. I'd like a battery because my brother has one. Well, we'll give you as many batteries as you want, but it's a stupid decision. Depending on the scenario. We'll go through that. So, Johnny, do you want to maybe take over here and just give people an idea of?
So, as Shane said, the first place we're starting is just trying to understand the consumption within the house, what uses how much electricity, and kind of just to get a feel for devices. So boiling a kettle, very tangible for everybody. So that's 2,500 watts. We'll say it takes 5 minutes for it to boil. So that's that many kilowatt hours. At 25 cent, it's costing you in around 5 cent every time you boil the kettle. So just to give a kind of a ballpark. Similarly, your toaster, we'll say it takes 3 minutes. That's costing you around 2 cent at a rate of 25 cent. If you spend an hour ironing, it's costing you 38 cent. So maybe that's a incentive to not do the ironing. Electric shower. So if you've an electric shower that heats the water as it's passing through, not just a pumped electric shower, if you like. So if you're using that for 5 minutes, that's costing you 17 cent. And your dishwasher, on average, uses in around 1,000 watts, running for 90 minutes. It's costing in around 38 cent as well. So that's just to give you some sort of a feel for how much electricity each of those items is using in the house, and kind of a cost. I've assumed 25 cent for all of these. We'll get into electricity tariffs later on, and that can vary, but just that you can compare like with like. So yeah, just to give you a feel for what each item uses.
Before we go away from that, you're going to see two terms here, maybe not so much, but in general, you'll come across power and you'll come across energy. Some people think they're the same thing. I suppose to the layperson they are. But power we might equate to something like my shower. My shower will give me 10 litres a minute, right? But, you know, over 10 minutes, that means I'm going to get 100 litres. But so one is an amount. So the 100 litres is the amount of water I used. The 10 litres a minute is the rate at which it arrived. Okay. So the power is a rate. It's like speed in my car, 100 kilometers an hour. The kilowatt hours is like distance. It's an accumulated amount, but it is an amount, right? So one is distance and one is speed. In this case, power is speed, and the other one is distance. Okay, so we're not going to be going into it too much. Try not to mix them up because you end up, if you don't try to understand it, you'll never understand it. You know, if I was to drive 100 kilometers an hour, how far would I go? Well, how long, Shane? Is it 2 minutes? Is it 2 hours? Is it over 3 years? You know, they're very different things. Yeah. But they get mixed up consistently.
Yeah. So the iron is the easiest one here. So that's 1.5 kilowatts or 1,500 watts. That run for an hour means that it's 1.5 kilowatt hours. So if that was to run for 2 hours, that'd be 3 kilowatt hours is what it'll cost you.
Exactly. And I multiply that kilowatt hours by the cost per kilowatt hour to get the resultant. So
yeah. So yeah. So just to go into a little bit more detail in household items, the incandescent bulb, which was out for long enough, a 60-watt bulb, which is kind of fairly average one, that's run for 10 hours. It'll cost you in around 15 cents. The new LED bulbs are 10 watts, but they're still providing a similar or a comparable amount of light. That run for 10 hours is 3 cents. So I suppose what we're trying to say here is as you're updating your lighting, go for the LED bulb as opposed to just replacing a like for like incandescent bulb.
Well, or the same goes for your tumble dryer or your fridge, or over time that
Yeah.
you're making I'm going to say informed or educated decisions, that there is a knock-on effect. I think more and more people understand now that the little BER symbol or the energy symbol on it now means something, whereas when it came out in 2005 or 6, it was an irrelevant thing that we didn't even think about.
Yeah.
So I'll read those, Jenny. Do you want to keep going with that?
So just another comparison, your conventional oven, you have a heat up time and the whole lot in it, and it's slightly larger because it's slightly larger space. So cooking, I would say something for 15 minutes probably costs 31 cents in a conventional oven. The new air fryers, you can use a smaller element to heat up because it's a smaller space, and it can be done in a shorter period of time. So your equivalent cost of that is around 9 cents. So just again to compare your power and the resultant effect that has on your cost. Energy monitoring for all these, where you can get both of these pieces of equipment are relatively cheap. The one on the left there is a very simple one. You buy it, you plug it into the socket, and you plug whatever you're using into the front of that. And over time, it'll tell you how much energy it's using on that screen. And then you can multiply that by your cost of electricity, and you can get a feel for what it uses. You can change the setting on that to get instantaneous power as well. So to see what rating your kettle is, whether it's a 2 kilowatt or a 2.5 kilowatt, So not expensive bits of kit, and interesting if you are interested in that sort of stuff, to go around, plug it into different things to see how much energy it uses. The one on the left is the most basic one. The one on the right is for if you want an app and the Wi-Fi enabled, and you can put multiple ones onto the one thing, so you can see a number of different things. Yeah, and just on your energy consumption as well, if you have a smart meter, your ESB online portal has a lot of data there that you can use to see how much electricity you're consuming. So worth checking that out and registering for that. You can download an awful lot of data and see how much you're consuming when you're consuming it. It's half hourly, so it's every 30 minutes. And also what you're putting back onto the grid, if you have solar, it will be evident there. So it's a good, there is a question there about how to know when a battery would be a good idea. If you want to go really into the detail, that half hourly data would tell you how much you're exporting and when you're exporting it. And then you can say, if I had a battery, that would save some bit of that.
We'll be looking at battery profiles here in a few minutes, and we can see then whether a battery makes sense. So we'll be going into that, and we want to go through a bit of housekeeping first of all the things that add up, and then we'll be talking about kind of philosophies. Okay, I have this scenario, I have a car, whatever. Okay, well, what's my best bet going forward? So we want to go through a little bit of this stuff first, and then we'll start talking about individual cases maybe as well.
So electricity suppliers, your 3 electricity suppliers, three approved comparison websites: Bonkers, Switcher, and power2switch.ie. So worth going on, you can go on there, put in your energy usage, and it'll tell you how much electricity you're consuming, or where you could save electricity. This is the list of electricity suppliers there. So you can, I suppose this is all about getting the best rate for the electricity that you use. As Shane said at the start, every year it's worthwhile, at least at the very least, threatening to leave your supplier, but shopping around to see what's the best offers out there. So just to explain the different types of electricity tariffs that are out there, there's flat rate, time of use, prepayment, and dynamic tariffs. Now, dynamic tariffs were originally supposed to come out in October this year. It's been pushed back to June. But what dynamic tariffs are is it's kind of like your tracker mortgage. The tariffs are set against the wholesale electricity price. Now, we don't know how much more will be added onto it and what it'll look like. The reason it's been extended out is to give suppliers a bit more time to get their head around it and how they want to structure it. But it'll be when there's, it's all to promote when there's a lot of wind maybe on the grid or a lot of solar on the grid, that it'll allow you to consume electricity very cheaply in that half an hour slot, as opposed to kind of 8-hour blocks.
Or it also wants obviously to discourage people from using big machinery or going mad at 5 o'clock in the evening when everyone is boiling the kettle and cooking the dinner. So and putting big pressure on the grid. on the grid. Yeah. So,
so they're your consumption tariffs. There is export rates obviously for your electricity. So depending on the electricity supplier you're with, these are your export rates that you can get. That's for selling electricity back to the grid. So that's, some of those are quite generous, and over time, the market, I suppose, will dictate what will happen to that. Possibly it could end up going down a little bit, but it probably was kind of more on average 25 cent a few years ago, and but slightly coming down towards the 20 cent and 18 cent at the moment.
Again, so I suppose to feel on top of that, if you were going to be exporting an awful lot of electricity, you should worry about the costs. If you are working from home and you have a relatively small solar array, well, in that case, you're going to consume the vast majority, maybe 80 or 90 or 95% of the electricity you're producing. Well, then you're going to be exporting very little. I would say don't get carried away or don't start sweating over the cost or the value of what you're getting. It'll amount to very little over the year. So some people are getting bogged down there on things that don't amount to an awful lot of money at the end of the year.
Yeah. So just to show the rates in graphs. So your flat rate, obviously there is whatever 24 cent all the way across the board. So no matter when you use electricity, you're going to be charged 24 cent per kilowatt hour. Variant on that then is the time of use. So what that is you're paying slightly more during the day, and you have this bump at peak hours. So this is between 5 and 7 o'clock, as Shane said, when a lot of people are using it. But the electricity tariff goes up, but you do get the benefit of this lower tariff at night. So that can suit if you have a battery, or if you can maybe delay some operations. That's where you want to be consuming your electricity, if at all possible. You do have another tariff, again, depending on your supplier. There's a lot of variable tariffs out there, but kind of this is the principle of the three most common ones. The night boost one. So you have a low night rate, but you have a big drop here. So it's down to kind of 8 cent maybe between 2 and 4 o'clock. So they give you a really cheap rate if you consume as much electricity as you can here. And then during the day, it's up at 31 cent in this rate. So basically it's a balancing act between getting night rate electricity and day rate electricity. How much do you use at night? How much do you use during the day? And where this night boost kind of comes into play is if you are forced charging a battery. So if you're telling your battery to charge at night, that night rate there can allow you to get very cheap electricity that you can use later on in the day. So that's where the night boost comes into it. Also, charging cars and that sort of stuff at those times is obviously beneficial. So this is just a kind of a snapshot of an electricity bill to give you an idea of, I suppose, how to maybe understand it or try to get a better feel for it. So this particular bill has no solar. So there's the night rate here. So this is the amount of units that we use at night rate, 354 kilowatt hours. We use them between 11 p.m. and 8 a.m. So that's over the course of those 61 days. So that's that kind of highlighted area there is when those kilowatt hours were used. Peak time then, we used 81 kilowatt hours between 5 and 7 on the 61 days. And again, you can see the cost of that there. And then all the other times, so kind of between 8 a.m. to 5 p.m. and 7 p.m. to 11 p.m., we use 453 kilowatt hours, and that's the cost of that. So that's your kind of ESB bill, or your bill looks slightly different depending on your supplier, but that's the principle of them all. When you add solar to this, so you can see this bill has solar and they have a slightly different tariff setup. So they have the what this supplier is calling the EV rate. So at the between 2 o'clock and 6 o'clock, they have a very low rate of 8 cent, 8.14 cent per kilowatt hour. And they're using 700 kilowatt hours during that time. They do have an electric car, even though that's not what the rate. You don't have to have an electric car to get that rate, but that's they're choosing to charge their electric car at that time between 2 and 6 a.m. every during the night. All other times then their rate is 36 cent per 55. So they have 900 kilowatt hours that they used in these 62 days for that time. So that was the cost of it. So the type of tariff, and there's, as I said, multiple options out there for tariffs. A lot of it depends on how you use your electricity, how your solar is being generated, and if you've batteries that you want to force charge, or if you've an EV charger that you can shift some of that electricity load to nighttime. So you can see here their units, 2,000 units of electricity were consumed, or were, sorry, put back onto the grid. And in this, with this supplier, they're getting 20 cent per kilowatt hour. So that's then credited from their bill. So you can see I suppose the benefit of having the solar there. Obviously what they're consuming, we'd say, stays the same, gets reduced slightly by the fact that there's solar on it. And then the export tariffs are credited from their bill. So obviously we want to consume as much as we can in the trough when the 8 cent electricity tariff is there. So in this case, or in this case, we want to consume it at the, whatever it is, 14 cent per kilowatt hour, the lowest kilowatt hour we can. A lot of the modern appliances out there now have the delay start option. So your dishwasher, your washing machine, your tumble dryer, all probably have this delay start. So you can put it on when you're going to bed at whatever it is, 10 o'clock, but tell it not to start for another 2 or 3 hours. So this one's not starting for another 3 hours, 19 minutes after this. So that means that the main consumption of electricity for the appliances happens at the cheap tariff rate. So worth being aware of those and aligning those with the cheap tariff. Sorry. Yeah. Electric car is obviously also something you want to charge at night if at all possible. So charging your electric car, and we'll go through some figures on the difference between the electric car and petrol cars, just to give you an idea. So your typical mileage, we'll call it 15,000 kilometers per year. In a petrol car, an average of maybe 7 liters per 100 kilometers, which means it's using around 1,050 liters. At €1.70 a litre, depending where you are in the country, that might be what it is, or up or down, but you're looking at around €1,785 per year to run that for petrol on that car. As a comparison, an electric car, the consumption is roughly around 15.9 kilowatt hours per 100 kilometers. And you get around 2. So that means that in order to keep that car charged for the 15,000 kilometers, you're using 2,385 kilowatt hours. If you were to use a 25 kilowatt hour or 25 cent per kilowatt hour rate, so that's your kind of, we'd say maybe day rate, that's 596 euro compared to your 1,785. If you can switch it to do it all at night, we'll say generate or charge 100% of the car at night rate electricity, you're down to 200 euro per year, as against your 1,785. So the running cost for your electric car is significantly cheaper than what you would get with petrol. If you do use, just I suppose there's more network out there for public charging points, and there is the high power ESB chargers that are out there. They typically probably charging around 66 cents per kilowatt hour, which obviously is an expensive way to charge it. But what it does do is it gives you a full charge within kind of 30 minutes, or at least 80% within 30 minutes. So the benefit of the ESB charging rate is your speed of charge is increased, but you are paying extra for that. So charging it at home is the best solution. So charging it at home, I've used a Zappi car charger terminology here. Shane said at the start, there's an awful lot of different technologies out there. And so it's impossible, unfortunately, for us to cover every one of them in this time. So I've used Zappi as being kind of the most common one, but the principle remains the same for a lot of the car chargers. So the first setting is eco charging. So what this does is it ensures that there's a kind of consistent trickle charge. It'll use all it can from the PV, but if the PV is down, it'll take kind of typically 1.4 kilowatts from the grid and use that to charge your car. You have the Eco Plus charging, which is solely from solar panels. So it'll say it'll only use the excess electricity that the solar generates and put that into your car. So if it's a really sunny day, you'll get a good charge out of it. If it's not so sunny, you possibly won't. And then you have the fast charging, which is the full 7 kilowatts, or if it's a 3-phase and 22 kilowatt, that all goes into the car, and your car gets charged as fast as possible. So no matter how much solar you're generating, your car charger is going at full tilt. So just to give you an idea of the time for charging, 60 kilowatt hour battery I've chosen here just for an example. If you were to charge it at the 1.4, it'd take 42 hours to go from 0 to 100%. If you're charging at the 7 kilowatts, it's 8.5 hours. So you can see the more kilowatts you put in, the shorter the time takes. And that's why the ESB fast chargers, they're 150 kilowatts, so they can get a lot of power into your battery.
Just to say there, most people won't be charging that from empty to full every day.
Absolutely, yeah.
If you're commuting your typical kind of 30 kilometers a day, you'll be only topping it up, half an hour, we'll top it up at low power there. So I wouldn't be getting, there are people doing 500 kilometers a day or 800 kilometers a day. They're the salespeople, and they're in that bottom line. But for your average person, you're talking about adding 10% a day.
Yeah, you're going from 70% up to 80 or 85 or something like that. So So on now to solar inverters.
Before you go away from that, just a few questions. So electricity credits. So how does accrediting work? Do you just mind covering that in the bill?
Yeah. So
or do you feel it was already covered?
We went through it a little bit. I'll just go back if I can find the slide. So this is where this is shown in the electricity bill. So your export units. So for this 62-day period, they produced or fed back to the grid just over 2,000 kilowatt hours, 2,007 kilowatt hours. They got paid 20 cents per unit of that. So that credit then came off their bill. So it was 488, so 448 plus the 40 euro VAT. the €401 credit, which is 20 cent multiplied by 2,000 roughly, means that this homeowner only had to pay €87.17 for this bill.
Now, if they were overall in credit at the end of it and they were owed money, if they were up €87 at the end of the month, that obviously rolls on to the following month.
Yeah, so if this was, we'd say this value was €500, there'd be €20 in credit here, and if your next bill was €100, you'd only have to pay 80.
Okay, well, before we go away from that,
Yeah,
a question, I hope people can hear me. Why do the ESB networks no longer provide opening and closing readings on my electricity bill? So they don't as standard, but you can request it from your supplier. Okay, that's the simple answer to that. Long and short of it.
yeah.
Yeah, I'd say, yeah, that's that. Tom Collier is asking, where can I buy the energy monitoring gadget? Hi, Tom. I would say Tapo is the one that we would use. You get it from the likes of Hennessy's Electrical or any of these fellas. You can get essentially 4 plugs they're about €60. That's kind of your entry level, but Tapo are a good make, and it's kind of like what John is showing there on the right hand side of that picture there. It'll tie up feed information back to your phone. And yeah, but you get them on Amazon as well. The only thing is, some of them, the cheap ones, will only give you instantaneous power. So if the kettle was running at that particular second, it would show 2 kilowatts. 5 seconds later, when the kettle is off, it'll show 0. So depending on when you look at it, you'll think it's high or it's low, but it doesn't give you a picture over a week or a picture over a month.
Yeah.
So you want the kilowatt hour.
And just sorry as well, just with the tapos as well, guys, you can actually program appliances to come on. So you can actually use the app to program different appliances when you want them to switch on and off. So they're very useful for the likes of that. They're not just energy monitoring.
Yeah, they're equivalent of timers
Exactly,
as well.
yeah.
You can set a timer.
So they're very useful.
Yeah.
Tapo is the name anyway, so you can buy them online or buy them on any electrical wholesaler.
Yeah, super. Now there's a question there actually putting something into standby, that the standby surely is wasteful. Just to put into context there, if you have a tumble dryer on standby, it's probably pulling, I'm going to say, a watt or probably 2 watts. If the tumble dryer is running, it's pulling 2,000 watts.
Yeah.
Okay. So we know about turning off televisions and stuff like that when you're going to bed, but you are talking about watts as opposed to thousands of watts.
Yeah.
So in that case, yes, turn off the things that need to be turned off for sure. But if you can put off something
From its big consuming,
yeah,
then it should
like your dishwasher.
Yeah.
Your dishwasher, obviously you can't put off the kettle until the middle of the night or whatever, but the things that you can, I certainly would take the little hit on the
Yeah.
standby.
Like there's very little win from a phone charger, probably uses around 7 watts or something like that, I think. So there's very little of a win for you by delaying your phone charging by night, because it's not a big consumer, whereas your dishwasher and your washing machine are in 1,000 or 1,500 watts. So there's a big win from delaying that.
Yeah. By the way, a heat pump, you could do the same you shouldn't do it in every case, but there are times of the year where your heat pump is not under pressure, where you don't have to leave it run for 12 or 14 hours a day. You could, if you wanted to, actually, in the milder times of the year, you could actually squash it and force it to run at night rate electricity. Now, you're losing a small bit of control by taking half rate electricity, but some people are happy to deal with that. If it's 20 degrees or 20.7 degrees, they don't care if they're after taking 60% off their electricity bill. That's maybe in another talk where we talk about heat pumps and operating them properly and getting the most out of them. Where as a nation, we're told you can't turn your heat pump off, you have to leave it on all the time. You can turn it. I know Johnny is napping. Shane is on his
the rest of the webinar will be talking about heat pumps unless we interrupt them here now.
But again, we want to apply common sense onto this and don't just take the advice down the pub at face value. We should be questioning things, and that's what we're doing in these talks. We'll get it.
Yeah, we'll send out there's a couple of people asking for the Tapo. We can send out a link with the follow-up email after this webinar. I'll let you go through.
Yeah, we're working away.
So we've gone through the electric car. Sorry, I'll find out. Oh yeah, sorry. So the next thing we were looking at is inverters. So again, depending on the solar system you have, that dictates the type of data you can get on your solar information. So the most basic inverter is a string inverter. If you've no batteries, that's possibly the inverter you have. So that will just show you how much electricity the system is producing this is over a day. So you can see obviously there's nothing being installed or generated at night. Over the day, it's fluctuating as clouds or trees or whatever it is. And then, but in general, it's the standard day bell curve. This is then with a hybrid inverter, so you get a lot more data. Well, there's a lot more information required because you've batteries and all that, which are charging and discharging. And you have the grid, how much you're getting from the grid and what your load is as well. One of the reasons why you have this additional data with the hybrid is because you have a CT clamp, this clamp on your, well, it's either in your meter or going into your fuse board, basically. But that measures how much electricity is coming and going into your house. Worth saying with string inverters, I think with all string inverters, you can get an add-on. Yeah, you can. So you can put in this CT clamp and plug it in to the string inverter. You do need to be able to run a cable from the meter box all the way into the inverter location. And I think there's a software, or is there?
There's a kilowatt hour actually goes on to it as well.
Okay.
Kilowatt hour is a smart meter as well.
Okay.
That goes on and ties back.
So, yeah.
So, but it is additional cost, and sometimes it doesn't fit in the meter box because you have to disconnect the mains.
Okay.
Coming in, so it's able to monitor everything and keep it back.
Yeah. So yeah, so I suppose that's just understanding why if on my solar system I can only see very little information, but maybe on my neighbor's solar system they can see loads. That's depending on the inverter might be one of the reasons for that. So you can see in the bottom one you have your PV, you have your battery, so how much of it is charging and discharging, what you're getting from the grid, what the total load is, and the state of charge of the battery. So expected generation, then what you'd expect to see from your system. These are rule of thumb and rough figures. Unfortunately, there's an awful lot of variables in there. There's the orientation, there's the location, whether you're in Donegal or Kerry, the orientation the panels are put at, whether they're on an east-west roof or on a south-facing roof or maybe a southeast-facing roof. You have the panel type, so you can have different outputs from different panels. You can have a 440 watt or a 580 watt, and then your inverters, obviously there's a wide range of inverters out there as well. But in general, just to give you a bit of a feel for what you should expect to see, in a January day, maybe something between 0.3 and 0.6 of a kilowatt hour per panel. So if you have a 12 panel system, that's coming out at around 3.6 and between 3.6 and 7.2 kilowatt hours per day. And if you have an 18 panel system, it's 5.4 and 10.8. So that's just what we'd expect to see from a system. In June, obviously, those figures go up. We'd expect to see between 1.5 and 3 kilowatt hours per panel per day. So between 18 and 36 kilowatt hours if you have 12 panels, and 27 and 54 kilowatt hours if you have 18 panels. And then in August, I just picked as a kind of a current one, somewhere between 1 and 2 kilowatt hours. So you're getting 12 to 24 based on a 12 panel system and 18 to 36 on kilowatt hours on an 18 panel system. Again, very broad strokes. You see the ranges there are quite large. Annually, we'd expect somewhere between 280 and 370 kilowatt hours per panel that you should be generating. And again, all those variables in there caveated with all that. So 12 panels, you're looking at somewhere around 4,000 kilowatt hours. With 18 panels, you're looking at maybe around 6,000 kilowatt hours. So the purpose of that, I suppose, is just to give you an idea that if you're seeing that you're getting 20 kilowatt hours per panel over the course of the year, there's possibly something not right with your system. So just to give you a feel of if you're getting 278, it doesn't mean that it's a catastrophic system or anything like that. It just might be the orientation is, and you're getting it for longer during the day. So
I suppose once a week we'd be asked there, guys, you know, is it possible that one of the panels gets hit by a football and goes down or something? And how would I know? Well, number one, you know, John will be coming to it in a second, when we install all these systems, we install it and then we put on a little testing rig onto it, which at the same time is watching the sunlight outside, and we can compare what the system is generating to what we expect it to generate given the sun. And so we can see that it's doing what it should or not. And then if for any reason over time that something drops, it might be, I don't know, a rat ate a cable. I don't know if that's even possible, but you know, he'd be dead anyway, obviously. But apart from that, but just say it did happen, that you know what to expect. I'd have to say on the other side, solar is extremely resilient. There, you know, it doesn't get airlocked. It's not like maybe the old solar thermal. If it wasn't serviced, it could the liquid, the antifreeze that was inside, and it could thicken up and it mightn't flow. You get airlocks, and all of a sudden it's not working. That doesn't happen with solar thermal or solar PV. It's guaranteed, as we know, for 25 years with most manufacturers. So it's bulletproof, but still in all, that people get a feel that it's where I'm happy with where it is, or should it be more, should it be less? That's kind of a ballpark, so that it
Just one thing on maintenance there, Shane, just as you're saying, so obviously the lower the angle of the, would say like a flat roof system, I have a flat roof system myself, and you will see compared to the 35, 45 degree angle on your roof, you will get a lot of dust and settlement on the panels as well. So that does bring down the efficiency. So it's no harm. If you have access, obviously, you know, it's safe to do. Give it a quick look, give it a quick clean. It's, you know, hose, a bit of a brush. You won't get electrocuted, don't worry. So just keep that in mind, just that the panel is able to absorb all that light. So it's something very simple, but just to keep an eye on it.
we see it in industry sometimes. If it's at the 35 or the 45 degrees, as Brian is saying there, the nature of it is they're self-cleaning, they're slippy, so when water falls on that, the dust actually just runs off it. But obviously if it's flatter, there's less of an inclination for the water to carry the dust away, so on. So that's worth saying.
This is what Shane was, I suppose, just discussing there. Typically, you're depending on the number of panels you have, but they're in strings. They're wired together in strings, and each one of those then is connected into your inverter. So this case has two strings, but each of these strings will tell you, we'll be able to read a voltage and an amps off it. The voltage, it tells us the number of panels that are connected, depending on the panel type, that voltage can be different. And the amps indicates how sunny it is outside. So just a couple examples of that. So this is 445.6 volts. So that's 12 440 watt panel system. And you can see it's quite sunny out on that particular day. This is then 8 580 watt panels in that particular string. So this whole system could have maybe 16, which would be 2 strings of 8. And that would come it's a slightly more overcast day there with 7.49 amps. And then this is 7 440 watt panels again. So we again probably a 14 panel system. But your voltage there tells you how many panels are onto it, and then your amps is dictating the sunlight on it. So that's just one of the tests that we do, or that every solar company does in reality before they leave, to verify that, okay, I can see that I've 8 panels on this string. What's the voltage I'm expecting to see here? And when I plug in my meter, is that what I'm getting?
I suppose every now and then you'd have a fear that somebody, the fear among the public is, what happens if one of those connections is out or something like it's not possible that one of them is not connected. Well, if one of them is not connected, they're all disconnected. And so anyway, so we, as I say, it's fairly bulletproof. When we leave site, or when I don't know that that's true, by the way, that everybody does this. I've no idea.
Sorry, but, well, I'm assuming and maybe hoping that they do.
But anyway, so it should be beyond discussion. And as I say, all of these panels, I would say all of the tier 1 panels, the manufacturers are guaranteeing their output for 20 or 25 years, maybe 30 years. So if you bought it this year, they're guaranteeing in our case that in 25 years time that it'll be producing 85 or 86 or whatever it is or more percent of what it will day one. So there is a deterioration over time. We would expect that, but it's not catastrophic. Maybe something like an oil boiler that drops away significantly over time, or a gas boiler. These don't. So anyways, just look, we get a lot of questions on it. We can move on.
Yeah. So the next thing I think is we just look at batteries. So there's going to be a few of these graphs, but what this is showing is the state of charge of the battery. So it starting off here at whatever that is, 62%, I'm going to say, going up to 100% and going down. This is over the course of a week. So between the 8th of October and between the 10th of August and the 16th of August, American dates. So we can see every day here the battery is discharging and then getting back up to full charge. That battery is not really doing the full work that it could be doing, because it's not fully discharging every day. And you're not getting your value of all the electricity that you've stored in it.
Well, you just say it's not that the battery isn't doing what it could be doing. The battery probably shouldn't be installed here. It's not the battery's fault.
Yeah.
There's no argument here for a battery.
Yeah.
So the battery is full all the time. So a friend of mine had this. He works for Bord Gosh. He put in solar. He put up a big array. His battery, in his case, he wasn't using much electricity overnight. It was a passive house, so he wasn't using an awful lot. So in his case, we analysed it and looked at it. He wouldn't have used a lot. If he had put in a battery, it would have just been full all the time. And the minute it's full, you're having to export the excess anyway. So you're paying an awful lot of money for a battery to be full, and an hour later you're exporting, you're back to square one.
Yeah.
So in his case, it's not the same in every case, but it depends on the scenario. But this battery certainly, I would argue, should not be installed.
Yeah, yes. This is I suppose, a battery you're getting a much more of a discharge on it. You can see it's going down to kind of 30% there and 20% here. So they're getting a lot more discharge. So this battery is earning its keep a lot more than the previous one. And in the next version, you can see this battery is being fully discharged every day. Now, the time that it's fully discharged is quite small, so it's probably I'm going to say the perfect scenario for a battery. If we were getting large gaps here, it's possible then to consider a second battery, but probably not. Again, you don't want the second battery to look like this. You want to make sure that you're getting the full discharge from the second battery when that goes in as well.
Now, the other thing to consider there when we're talking about batteries discharging is when you buy a new battery, they have I won't say a set, but they have a guaranteed amount of discharges. So you can buy a battery that can discharge, they call it cycles. It can be 8,000 cycles, it can be 10, 12, 15,000 cycles. So, but at the end of those cycles, your battery will probably need to be replaced, or it'll certainly be less efficient. So when we're forcing discharges or we're forcing nighttime charging, each one of those is a cycle. So if we think we're making money or saving money, we want it, and I don't want to make it too complex, but there are people there who think they're doing intelligent things, and they might even be very close to doing the right thing. But sometimes the cost is they've added extra cycles, and now they're going to have to replace the battery 5 or 6 years sooner than they might have. So it's penny wise, pound foolish, or and so on. So I just keep that in mind.
Yeah. I think that's basically it. Brian is typing away there to some questions that are maybe more specific. Just one of them here: do you have to be on a smart meter plan to see your usage data? Yes. Sorry, not a smart meter plan, but you do have to have a smart meter. So that half-hourly data is only available through the smart meter. It's not available through other meter types, the old meters. I think the smart meter rollout is now due to be finished by the end of this year, even though I think it was last year at some stage as well. But most houses should have a smart meter now. So sorry, I'm just going through some of the questions.
There's questions there on CPD certs. How do I request a CPD cert? Just type in your email address, Hugh, and we'll look after the rest. We'll fire them back to you. There's a few questions like that, but just your email address. We probably have it in the background here anyway. We're happy to send them out. It'll be this evening or Monday.
There's just one question there from Kieran Lauren about the Sims app. It's saying that it's generated more than it actually is. That's more than likely the rate is incorrectly set on the app. So that's a simple fix. So we can get one of the guys in service to easily adjust that. So we just need to know your rate, and then we'll be able to adjust that on the app. That's no problem. So we'll get that sorted for you, Kieran, right?
So yeah, so the Sims app is the app for GoodWe. Each of the inverter types have a separate app that you can log in to view. Sorry, I'm just trying to find a slide that might help here. Yeah, so what the app is reading, sorry, it's the wrong one. What the issue we think there, Kieran, is that it's reading a correct amount of kilowatt hours that's being exported, but this 20 cent is incorrect.
In the app.
Yeah, in the app. So aligning that with what your actual export tariff is what needs to be done there in order to get you the right euro figure showing.
So one of the first questions there was to do, can I see it again, John?
Sorry.
Just so we make sure we're answering it. How do I know when a battery would be a good idea? So what was the conclusion of all our charts there?
Yeah, so if you want to get really into it, your consumption here on the ESB portal will tell you how much electricity you're exporting and when you're exporting it, and you can then do an analysis and see, okay, it's going to be a 5 kilowatt hour battery. How many times can I fill that 5 kilowatt hour battery and then consume it afterwards? In order to establish, okay, will my battery be worthwhile?
So simply, that's what happens when you ask an architect a question. Simplistically, if you're not exporting anything, you should, under no circumstances, have a battery.
Yeah.
If you're exporting a lot, we should start considering a battery, and then we go into that analysis. But if you're not exporting, so in other words, if you had, say, 6 panels up on your roof and you're using all of that as it's arriving, under no now you could put in a battery and say, I'm putting it in because I'm using it. I have a philosophy that download nitrate electricity, but that's a different argument.
Yeah.
If you're exporting a lot, we consider a battery. Okay, so again, when you go into the bigger systems here, you start to come up against other questions. I have some questions here on clipping. We haven't covered clipping here. Clipping, oh yeah, sorry, there's another one. Yeah, so clipping occurs in anything that is energy related. It occurs in solar farms, it occurs in wind turbine or wind farms. It's where I have a license. For example, if I had a wind farm and I had a license to export, I'm going to say 5,000 kilowatts. So at any one time, I want to export 5,000 kilowatts. So I have two choices. I get my license, I pay a lot for the license, by the way. So in this case, I either put in 5,000 piece of kit, and on the days where it's not windy, I'm exporting 2,000 kilowatts or I'm exporting 1,500 kilowatts. So what most of these people do, and it's legitimate, they might put in 7,000 kilowatts or 8,000. So on the days where it's really windy, I have a surplus and I can't send it to the grid. The grid will not accept it. I'll be in breach of my contract. So we put in a limiting device. In this case, in our case, the inverter limits it for us, right? But the benefit of clipping is you can see on the windy days, I'm losing a bit, but for every other day, I'm exporting the maximum. Okay, so it happens right across the, as I say, wind, it happens in solar, it happens in hydro, or any of those. It's a proven and accepted kind of strategy that pays you back more. Now, some people think, okay, on the really sunny day now, I'm losing a bit, and that is true. You can't export it, right?
But on the other 320 days, you're closer to your limit, so it means you're closer to producing the maximum amount. So your payback is
Yeah.
a lot more.
So now how we have software in any given case. We take your house, say Michael here, we take your house and we say it's east-west facing, it's south facing, it might be even north facing. We put in your expected energy pattern. We put in the amount of panels, the type of inverter, what sort of a connection do you have to the electricity grid, and it starts to tell us then we should put in a bigger or a smaller inverter. We're putting in too many panels. We're putting in too few panels. But some of it we're in a domestic case, we're limited by what EirGrid will allow us to do. There are maximums unless you go up into the next more commercial export licenses. But then you're paying more for standing charges and all the rest of it. So so that's it. So anybody who wants more information on that, keep asking questions, and we'll stay with it if it's of interest. But I call it a contentious one. It is. People don't like that on a really sunny day that they're losing some. The philosophy is that on the lesser days you're gaining more than you're losing on the good days.
Yeah, and so overall, it's very definitely worthwhile.
Tom has a question there, a good one.
Yeah.
If I wanted to add a panel or two panels onto my existing array, it starts to get expensive, Tom. There's no easy way to say it.
Yeah.
You have a guy putting up the same cost to come out and put up scaffolding at your house, and he's climbing up to put on a panel, and where the panel is, I'm going to say 100 quid or whatever they are, you know, you're paying, you know, he could be doing something else on that day. So it's not that, you know, he could be making 500 euro down the road doing a full system. And so the reality is you won't even get him out probably.
Yeah. So in theory, for all of the first panel that you put up is kind of, I suppose, conceptually the most expensive, because that's you have to get there to do that. If you're doing 18 panels, obviously it kind of that balances out over the 18 panels. But if you're only adding an additional 2 panels, it's it does become a little bit expensive. And then there's another similar question there about if you wanted to change your string inverter to a hybrid inverter and then put on a battery. It's not that it's there's a lot of rewiring or anything to do. It's essentially taking out that string inverter, putting in the new one. There's a few extra cables that need to be run to the likes of your meter box there to ensure you have the CT clamp in and making sure you've space for batteries around it. So there's little bit of rejigging that's required, but you are getting a specialist. It's an electrician that needs to go out in order to do that. So it can be expensive. And also your string inverter that you paid for is now no good. So you're removing that altogether. So
now there's another one here, a question from Dennis, which is a good question. I have a generator and I've only run it without using power to the house, and I'm wondering, should I use it sorry, I thought it was a different question, but we'll answer it while we're here. Use its power for a better charge for the generator's battery.
So I think, is that using the generator to charge up the battery?
Yeah, if that's what it is, I wouldn't do that. It's going to be more expensive than. But can you decipher if we're reading that right? I'll answer it. The generator in general are having this kind of island mode for your house. So when when the grid goes down, a lot of people assume that if I have a battery, I can use the battery to power the house. There's a problem with that in general, which is that if you can imagine, the fireman comes in, and we have to worry about that day. The fireman comes in, he turns off the power at the side of the house, and he walks in, and there's 230 everywhere. So in the
230 volts, sorry, there's electricity everywhere.
Yeah,
yes,
okay,
yeah.
Sorry. So when the power goes off coming into your house, the simplest systems deliberately kill the solar, right? The more sophisticated systems, we can put them in. You can go into a thing called island mode, where you have an isolator switch at your mains, which isolates you from the road, as it were, or the grid. And so a lot of people assume that they're able to operate off their battery automatically, and it mightn't always be true. It's the switch that protects us from putting 230 volts back out onto the grid and killing the fella down the road fixing the cable. That switch is about €1,000, but there's a lot of there's a nice bit to be understood there. Do we have anything else to add to that?
No, just keep it simple like that. Is either you're either generating it yourself, or it's coming off the thing, off the main grid itself. It's
But I think that is the question there, is to charge your battery with a generator. No,
advise
it's
it,
not.
no.
No.
yeah, well, it'd be more
it's not the
expensive.
Yeah, it's not the cheapest way of charging.
Yeah. Generators are 30 or 40% efficient. So for every litre of diesel you're putting into it, you're losing a lot, and you're way better off charging it by night. I would suggest you're way better off even charging it by day off the grid.
Yeah.
So how are we doing on questions? I think we're down to the bulk of my hope.
Yeah.
So have you anything after that, John? We'll keep going.
No, I think we're done. A few more questions coming in.
Shane's question there, if you lived in an estate and the builders put up 5 panels, that would certainly have gotten them over the line in terms of building regs at the time, Shane. Would somebody be interested in coming out and doing a number of those together? I could see a situation there, Shane, where we would, now if it's in Donegal, maybe it might be harder for us. We're based in North Cork and so on, but we're doing a lot of estates now, but we have one of them actually only 2 hours ago came in, there's 75 houses in it. So we're doing a lot of them, and the rates are really good. So that might be worth touching base, Shane.
The other thing, sorry, just to bear in mind on the to see this data for the inverters, it's worth bearing in mind that you always need a Wi-Fi connection at the inverter location in order to see that data. So the inverter needs to be connected to the internet in order for you to get the data. And yeah,
now it's important to say that if you don't have Wi-Fi there, the system still works.
Yeah.
You just can't see what it's doing.
Yeah.
So we do have people every now and then, even though we say it in our quotes that we need Wi-Fi. The Wi-Fi might either be dropping continuously, which we come across regularly, and then we're having to reintroduce the app, etc. But some people actually, they have Wi-Fi, but they don't have it in the attic. And then of course Ashgrove are responsible for it because the app won't work. We do see it, we can understand it. Some people are having to leave there. Thanks for that, guys. Thanks for coming.
We're running over a little bit in time, and I've gone through, I think, all the slides. There's still a few more questions we didn't get to, but we might correlate those and go back. We just want to run through kind of the final takeaways. I suppose the big one, probably nothing to do with solar panels, and maybe some of the presentation had nothing to do with solar panels, but checking your electricity tariff is a big thing. Every year that you're out of contract, at least threaten to leave, if not shop around, and it'll get you a much better rate. As you're upgrading equipment, consider energy efficiency, so the LED bulb instead of the incandescent bulb. If you're on night rate electricity, delay whatever you can, and then monitoring your consumption, whether it's the house in total through the ESB platform. By the way, most suppliers have a similar platform to the ESB, which gives you data and how much your usage is, and some of them compare it to similar houses and all that sort of stuff. But understanding your consumption and the electricity you're using, and then understanding how much you're producing as well.
We will be sending out the presentation. We'll send the recording as well for anybody we'll send it out. We'll send the recording. We'll send you the presentation. Is there any other questions there that we need to do? So can I see, question is from Noel, can I see the performance without the app? The answer is no. Actually, Brian, is that true? If I was standing beside the unit with my phone, can I get the...
Yeah, if you connect it to the phone.
Yeah, okay. If you were standing beside it with your phone, Noel, you can, but only if you're standing beside it. Sorry, another person is just after saying that, actually. Perfect. Okay. My question for Brian, or maybe John, when the system trips, switch arises a few times a year, any way of getting an alert on your phone that it has tripped? When the system trips, is that
it should be active on the phone anyway.
Is there an alert that comes up through the app?
Through the apps,
it depends on which app that you have, whether it's a Goodway or Huawei, whatever, SAJ, Solace, they all have different apps. So it might depend on your individual app, but yeah, we can look into that for you there, Michael, and come back to you on that.
Yeah, Jerome's question there, any advice on how long to charge a battery at night at the different times of year? Jerome, unfortunately, there's now there is smarter technology coming where it's it'll
AI generation.
yeah, it's AI is actually making those decisions for you. So it's probably, I'm guessing, 6 months or a year away, but you're continually adjusting. I suppose the best thing, Jerome, and it's fine for me to say, if you have an interest in it yourself, you do a fair job. Some people might understand the concept but won't do it, but you are continually adjusting is the reality of it, Jerome. Yeah, I hope that's okay.
Super.
We're wrapped up with that. We'll
Yeah.
stay answering questions if anybody wants for a few minutes, but we're finished.
Yeah, Brian's just looking into that there, Michael, for you. Yeah, we'll send out the slides and the recordings after.
Yeah, there's a few questions to do with panel size compared to the inverter. The panel size, when we add them all together, is, I would say, in 99% of cases, bigger than the inverter side.
Yeah.
And that's going back to our export license and also the flipping question. So there's probably 4 or 5 questions there to do with that. Again, we're limited by the amount of electricity we can put onto the grid from a
ESP
house.
networks and dictate what's the max size inverter
Yeah.
can be put on. So,
And after that, it's a question of should I put on more? Can I fit more? Number one, and then can I put the more I put on, the better, provided the inverter can deal with it. There will be clipping, but it's still financially the right thing to do. I think we're to the end of it there. They're coming in dribs and drabs. We'll be here for the next hour looking.
Super.
Okay, so will I wrap up? So
Yeah.
Thanks to John and to Brian for we're going to be doing something like this for heat pumps as well. We don't know when. We've a lot of them on. As I said at the start, the idea is that over time that we improve the knowledge that's out in the public and in, I suppose, in the building world. And we don't have all the answers, as you can see, maybe there in some cases, but I suppose we'll try our best to get them to you if there's something we hadn't to hand, and we'll go and talk to the energy gurus upstairs here. So yeah, that's it. I think we're finished. There's few bits and pieces coming in, but we'll be here for the evening maybe. So thanks very much to my colleagues, John and Brian. Thank you for joining us. Feel free to reach out if you have any questions, and yeah, we'll talk soon. Have a nice weekend.
All the best.
Thanks, guys.